purpose of this presentation is to give you an overview of how to set up your BA-4000 link aggregator. Basically, from taking it out of the box to hooking something up to the LAN port and being able to use the combined upload speed of your 2 or 3 WAN links. So I have here a BA-4000 unit here at Value Point, and you can see we've got a couple links connected to it, and the links are up and the load balancing is active. So if this was a new unit out of the box, the first thing we would do is go to the network settings, and then whatever we had plugged into WAN 1. In this case, we have a PPPoE DSL connection. So this is when you want to connect the 4000 by entering the username and the password that your DSL provider provides to you. If you're using a DSL modem that's more like a router, in those cases you would just use DHCP, since all of the routing would be done in the modem itself. But in this case, we're actually going to put in our username password. So a few things to look for here after you get this information from your ISP is make sure you have the right MTU. So this is the maximum size packet that you can send over PPPoE, and it's different for different ISPs. The 1492 is pretty common, but it's entirely possible that your ISP may have a requirement where the MTU has to be a little bit smaller. And if it's not quite small enough, you can have a lot of network connection problems. So depending on your ISP, you may also need to enter a MAC address for the clone. And what that will do is that'll basically just let you enter a MAC address that they provide. So they may require you to enter some particular value here. Again, this is a question for your ISP. So once you have all those settings in, then you're ready to connect on the DSL as far as the modem is concerned. So in addition, you'll want to configure basically the speed of the link, and that's configured under the link ratio. The simplest way to configure this is to just enter in the download speed in megabits of the connection. So this DSL here is about 4 megabits, so we just have a link ratio of 4 here. The way this ratio is implemented is that the ratios for all the links are added together, and then each link receives, a proportion which is equal to its link ratio divided by the total amount assigned. So in our case, the total is actually 9. So this particular link gets 4 out of 9, and the other link gets 5 out of 9. One thing to keep in mind here is that there's only one link ratio. So if you have a link that you want to receive more data for some reason, if it's more reliable or some other reason, or if it has a faster upload speed and you want people to be able to make more use of the increased upload speed, you may want to give it a higher link ratio so that it will receive a higher proportion of the traffic. And then the only other things you really need to look at for this WAN 1 connection is you want to enable the NAT if you're expecting to connect multiple users through this single connection, through this single IP address that you're going to get from your ISP. And then also pick one of the link detection methods. Basically, that's what's going to determine whether or not the 4000 detects the link as being up or down. So pinging a remote IP means that you pick an IP address somewhere on the internet, and then when you get a ping response from that address, then the port is considered to be up. In this case, this is actually the Google DNS IP address, which seems to work fine for most customers. Do keep in mind that this is Google's IP address, so they may stop responding to pings at any time. So just any time you're using an IP address that's not in your NOC, keep in mind that that you don't really have direct control over that IP address. But generally, using a remote IP is fine. Your other options are you can ping the gateway, so that would be the DSL modem in this case, or since the modem's in bridge mode, this would be probably the address of the DSLAM. Or you can do an ARP to that gateway, which is layer 2 based rather than layer 3 based. Or you can just do it based on whether or not the cable is physically connected or there's some device powered on at the other end. But of these, either pinging the gateway or pinging a remote IP are the two most common preferences. So on this particular unit, we also have WAN 3 connected. This is just a static IP address. So we have an IP address from our ISP. We entered these values that they assigned us, just double check and make sure those are the correct values. In addition, we actually have a block of IP addresses. You can see we have this 240 net mask. So we have about 10 or 15 addresses here. And another option you have on the static IPs is this option to do IP alias, which will basically cause the 4000 to respond on more than one static IP. So this particular 4000 unit will respond on this primary IP of .65, but it also will respond on .71. And there's a few different reasons why you might do that, most typically just to add more options to the port forwarding. You might have another reason to do so. Just keep in mind that this does consume one of your public IP addresses, and you won't be able to put another device on that IP address. The 4000 is going to respond to all traffic to that IP, just like it would this primary address up above. And then the other options are pretty much the same as a DSL. You can see here we've set the link ratio to 5. This link's a little bit faster than our first link. The other settings are the same. NAT is enabled. And we're still pinging your remote IP, but you'll notice this is the other Google DNS server. It's not a good idea to set the links to ping the same remote IP address, just in case that IP is down for some unknown reason. That will cause the port to show as being down, and if all your ports are using the same reference IP, then they're all going to report that they're down. So you could use the other Google DNS server or pick a different DNS server or some other public address that that you want to pick. It's really up to you. So that pretty much takes care of the WAN configuration. If you had a third link on DHCP, you could just set that the same way. And you can see the DHCP is a little simpler since it gets all that information from the DHCP server. So the next port that you want to configure is the LAN port. And in the case of a gateway, if you're hooking up a gateway like the controller 3560, this LAN address will be plugged into the WAN port of the 3560. So here you can see we've assigned address 1.1.1 with a 255.255.255.0 subnet mask. And if we take a look at our 3560 on the same system, we can see the 3560 is at 1.2, same subnet mask, but this is the WAN port on the 3560. You can see we're using pretty much the same DNS servers. But it's important to note that the LAN address of the 3560 is in a totally different subnet. So just make sure that none of these subnets overlap between the LAN port on the 3560, the WAN port on the 3560, which will match the BA-4000 LAN port, and then the public WAN port of the 4000. Make sure that those that those ports don't overlap, with the exception of the LAN and WAN ports that you need to connect. That's an easy mistake to make. Other than that, so the LAN port on the 3560 also has a DHCP server that you can use if you want. You can also provide DNS. In a lot of cases, you won't be providing any DNS addresses on the 4000, particularly if you have a gateway connected, then that gateway will be providing all the DHCP. But if you do have other devices other than the gateway or a separate network, you can use DHCP on this range. By default, there's some built-in DNS servers that those DHCP clients would get that just goes to a public DNS pool, or you can provide your own servers. Again, these are the Google servers, which are pretty popular. But really, any public DNS server is fine. Now, when you're aggregating multiple WAN connections, it is important to make sure that the DNS servers are available from any of the ports. For instance, if you have a primary ISP that maybe has your fastest 10 or 20 megabit link on it, and you use the DNS servers from that ISP, if that link goes down for some reason and your clients are still trying to talk to those DNS servers, they probably won't get a response from your other backup links. So it is important to use a publicly addressable DNS server here, whether you're going to use the Google DNS or OpenDNS or any other DNS server. Just make sure that it's not tied specifically to an ISP, or that the ISP is not not going to block other requests, since if that port goes down, all the traffic will get routed through the other ports. If we take a look at our controller, you can see in the DHCP server on the controller, you can see that those users are all going to get either 888 from Google, or else their secondary is going to be 208.67.220.220, which I think this is OpenDNS. So going back to the 4000, that pretty much covers the LAN port configuration. The only other thing that you need to enable to basically be ready to go in terms of the aggregation is to actually go into the load balancing settings and set these up the way you want. If you want to have a system where the ports are load balanced based on the link ratios and traffic is sent through all the ports at the same time, then you want to use the load balance and failover. What that will do is each port will get a portion of the traffic related to its link ratio. If a port goes down, that'll be detected according to this link check interval, and then within that interval, or after that interval is expired, then the traffic will be routed through the other remaining ports. If you set the configuration to failover only, then in that case only when the highest ratio port or the fastest port is down will the traffic then be sent to the second highest port and the third highest port. So you may want to use something like this if you have a very high-speed link, like a 20 or a 50 megabit link, and then a slow, backup link for emergency only, or maybe that is used for a back office that might only be 1 or 2 megabits. And if it's, if it's not worthwhile to be load balancing the traffic, you might set it to failover only. On the other hand, you could just set it with a very low ratio, and only a small amount of traffic would go over that port in any case. So once you've set all these, your WAN ports, your LAN port, and enable the load balancing, basically you're ready to go. So if you plugged in a laptop at this point, you could browse to multiple websites and see the aggregate speed for all the links and test the links, being up and down. So as you can see, it's quite simple. It's not difficult to understand. And we'll cover some more advanced topics in some future videos. Thank you very much, and please contact us at support@valuepointnet.com if you have any questions about setup or about this particular presentation. Thank you very much.